Hi, this is Professor Poyo, and this is the third part of Chapter 10, Data Analysis and Statistics. And in this video, we're going to look at variation or variance. With variance, we will specifically be looking at the mean absolute deviation, or MAD, M-A-D, and standard deviation. We will calculate both of these and talk a little bit about a normal curve and how it measures distance. When you're looking at variance, you're measuring distance away from the mean. And so very important to always remember that distance is a positive number. If you're thinking about traveling from one place to another, if you were to measure the distance that you traveled, it would always be a positive number, whether you are going to a specific place or returning from that place. So in this slide, what I'd like you to see is that in a normal curve, right here in the middle is your mean, or your average. Remember, when you take all of your data scores and you add them up and then divide by the number of scores that you have. Well, in a normal curve, 68% of your data falls right within one standard deviation of your mean, which means either one standard deviation below, all of this area here, or one standard deviation above, all in this area. For mean absolute deviation, there are 5 steps that you take in order to obtain or calculate that number. First, you're going to find the mean of your data. Then you subtract the mean from each of your data values. Third, you find the absolute value of each of these. Then you add the absolute values together and divide this sum by the number of values in your data. Notice that right here, step number 3, because you're finding the absolute value, this will ensure that your distance away from the mean is a positive number. Here's an example. Suppose we had these test scores, 99, 99, 84, 67, and 67. Okay, first we would find the mean. So we would add all of these up and divide by 5. Next, we would subtract our mean, whatever that would be, from each of these values. The mean subtracted from this value, these two values, may end up being a negative number. So for step number 3, we find the absolute value to be sure that our number is a positive number. Once we have those absolute values, then we add them all together and divide that sum by 5. The reason we divide by 5 is because we have 5 test scores. Now, if you look in your textbook on page 644, there is an example of that, and it gives you some help. It's actually this exact example. And when you perform your number 1, finding the mean, you'll actually come up with a score of 83.2. So that's what you would subtract from each of these scores up here. Now, calculating the variance and the standard deviation is a little bit different. Notice that first of all, you do the same exact thing as you did for your MAD. You find the mean of the numbers. That's always the most important. Remember, finding the mean means that you have to add all of your scores up and divide by the number of scores that you have. Secondly, you subtract the mean from each of the numbers. Okay, so far, step 1 and step 2 are exactly the same as what you do for your MAD, your mean absolute deviation. Now, third step, this is where it changes. Instead of taking your absolute value, you're going to square each difference that you found in step number 2. Now notice that if you square a number, even if it's a negative number, you will obtain a positive number. So this step, number 3, just like step number 3 for MAD, is the step that ensures that your values, that your numbers are positive. Again, remember we're measuring distance, and anytime you measure distance away from an object, it's going to be a positive number. Step 4, we find the sum of the squares from step 3. And then fifth, we divide by however many numbers we had, that's what the n is, to obtain our variance. So once we divide the sum of the squares by our number of data, that will give us our variance. We're not done yet though for standard deviation. In order to obtain the standard deviation, you have to find the square root of your variance, and that will give you your standard deviation. Now, if you look on page 646 in your textbook, you'll see up at the very top there's a formula there. One of the things I want to draw attention to is that in that formula you're going to see something that we would read as x bar, which basically is an x with a bar or a line right above the x. And you'll see that in that formula. Just remember that the x bar really is referring to the mean, and the mean is what you found right up here in step number 1. Okay, so let's practice. Here's our example. We have test scores here from Professor Abel's class. A 10, a 50, a 50, a 70, an 80, and a 100. Okay, first we're going to find the mean. If we add all of these test scores up, we get 360, and we see that there are 6 test scores, so when we divide by 6, our mean will be 60. Next, we're going to subtract that mean from each of these test scores. So, our first test score is 10, subtract 60. The second score, 50, subtract your mean of 60, and so on. Here are the values that we obtain when we subtract the mean from each of those data scores. Notice that there are several negative numbers. We're dealing with variance, which is distance, so remember we want to get rid of any negative numbers. So this is where we're going to do that. In step number 3, we take each of the values from number 2, right here, even the negative numbers, and we square them. Negative 50 squared gives us 2,500. Negative 10 squared gives us 100. Negative 10 squared gives us 100. 10 squared also gives us 100, and so on. Our fourth step is to sum all of these numbers here. When we do that, we obtain the score of 4,800. Now, if we divide that 4,800 by the number of data scores that we have, that would be 4,800 divided by 6, we get 800. Now, this is where you obtain your variance. Okay, so 800 is our variance. But in order to get the standard deviation, we have to take the square root of that variance, which is approximately 28.3. That would be our standard deviation. So the information that we obtain by performing these steps to obtain the standard deviation is to say that when we look at these scores here, our mean, or the average, is 60, and 28.3 is our standard deviation. So 60 would be right in the middle of that bell curve. One standard deviation above the mean would be 60 plus our standard deviation, which is 28.3. If we were to ask ourselves what one standard deviation below the mean would be, then we would obtain 60 minus 28.3, and that would give us the score of what would be one standard deviation below the mean. So this is the slide that we looked at a few slides ago, which I've come back to in order to help you understand the concept of mean and standard deviation and variance. Please make sure that you look at this and first of all know that this symbol right here is mean. That's what your mean is. And so on a normal curve, You reference your data by saying it is 1 standard deviation below or 1 standard deviation above, which would include 68% of your data. Or you might say it was 2 standard deviations below or 2 standard deviations above. But all of this is in reference to the mean, and you're talking about the distance it is away from your mean, how your data varies from each other, and how it varies from the mean. Please don't get frustrated with all of this. Rewatch the videos, practice, get your homework done, and I would even suggest, if you are still confused, perhaps look up other videos that are available on the internet. But I know you guys can do it, and I will see you soon. God bless.